The last time I gave a talk here was right after the election in 2016, so I hope the audience is a little bit more responding than it was then. Just a lot of people looking at the ground. All right. Is this the right thing?
Yes. Just do the share screen, Zach.
We're on, yeah.
No, once you go, it's gonna go back to.
So it's shared. You are sharing to me.
Yeah, but you're sharing from PowerPoint, not the, I have to click it.
Is this good? Okay, perfect. All right. So you've already seen the screen. So I'm going to talk a little bit about I guess some of our takeaways from the oVert project, which just finished, and Jamie talked a lot about this section here. But I'm going to really talk more about this and some of the things that you think would be obvious, and some of the things that are probably less obvious. So the museum, the oVert project just finished, and we have scanned what, 13,000 specimens, and almost double that in terms of the amount of media files that we've put up online. It's been a huge effort, and I would say that the data going up, I hope, will have a huge impact on not just research but education and artists, and all the things that Dave was talking about this morning. But I think for us as the digitization community, the takeaway, the thing that will hopefully have the most impact for us going forward is the oVert pipeline that we've been building and working with museum collections and data aggregators like IDBio and the repository like Morphosource and Sketchfab to integrate this and build a fully integrated pipeline that funnels data into the public sphere. So we just had the paper come out. There's been a lot of press, and the journalists that do call me always ask me, so what's next? And the obvious answer, of course, is that, well, the oVert project focused on neontological vertebrates. And so there's all of paleontology and lots of non-vertebrate neontological collections, like entomological collections or botanical collections, and also, 2 million other vertebrates that are sitting in collections around the world. So the oVert project doesn't end, and the digitization, the CT digitization doesn't end with oVert. And so we can use this pipeline to do entomological project, and you can CT scan insects just as well as you can CT scan vertebrates. Just requires a little bit more, higher resolution. We chose Morphosource as our repository because it intersects very well with museum data. In fact, it was designed to be used with museum specimens, right? So every single media file is pinned to a specimen, and that specimen interacts with or is linked to specimen records and specified through IDBio. So that's a useful tool, and I really want to kind of just focus on this portion of the work because this is the portion I think is a little bit of the bottleneck at the moment. We'll talk about the bottlenecks going forward, but the scanning of the data is not necessarily the hardest thing anymore. I feel like the part that people really lose steam with is getting that data into the repositories. So Morphosource is you have to sign up for Morphosource, of course, but it's a free resource. Once you sign up for it, you have to register as a contributor. So once you get contributor status, you'll notice some contributor tools in your dashboard here. One of which being batch submission. And that really does speed up a lot of the process. So we can actually upload large amounts of data, multiple files, all in one go, for those of you who haven't used it. So once you've clicked on that, you'll see this batch submission form. And you'll see that there's a series of basic details you have to enter about the group of media that you're about to upload. Ultimately, the individual metadata is filled out by using this Excel spreadsheet. So because you're uploading a lot of things in one go, thank you very much. The data needs to be from the same collection and the same collection in the same institution. It needs to be managed by the same manager or group of people. It needs to be imaged at the same institution on the same machine, right? These are all information. These are all information that is shared between all the media data that you upload in one go. The ownership and permissions remain consistent across the batch that you upload, so that has to be all the same. And if you wanted to assign it to a project, that's a grouping of media that isn't tied to a collection or a data management system. You have to upload it there. So then you upload all of your data files via SFTP, FileZilla, or CyberDuck to a server at Howard's at Duke, and then you build this batch manifest, which is an Excel spreadsheet, which has 50 fields. So 50 fields of the different data, right? So when we were doing this the first time, we thought it's not actually saving us a huge amount of time because we're just cutting and pasting out of the metadata files into this Excel spreadsheet. This is what this looks like. So you have, the media file here, the description of what kind of data it is, all of the, your ID bio specimen metadata, you have to fill that in as well. So it's actually time consuming as well. It doesn't save you a huge amount of time. So we built because I don't know how to use Python, I built an R script to basically scrape your metadata from either Phoenix systems, Bruker systems, or Nikon systems. So if you can gather all of your metadata files into a folder, you can run this R script, and it will build that batch manifest for you, which should save you a bunch of time. There's some things you need to standardize, like the metadata file names all need to be standardized and include the Darwin core triplet. And that allows you to pull down all the data from ID bio. The delimiters have to be consistent, and if you want to include a descriptor, you have to include that in the title, in the file name as well. And also the metadata and file names should match as well, right? That you can go back and fix that afterwards, but that's basically it. So that's how that will actually speed up the upload process and clear some of the backlog. Hopefully clear some of the backlog from all of our scans. And I really want to just finish, if I have a bit of time, just to highlight some of the other bottlenecks that's probably coming down the pike, and it was brought up by Austin a little earlier, which is, I think, we can put all this stuff up online, but until there is, until we curate the data for the people who are going to be wanting to use it better, we're going to be limiting the amount of impact that these data have, right? And I know this well because this is what most of the oVert data looks like, are these tomographs, right? And so people don't, educators and people who are just interested in museum specimens don't necessarily have the ability to turn these tomograms into a three-dimensional, object. They don't have. Well, they have the ability, they just don't have the training or the software access to do it, or even the knowledge to do it, right? And this has been quite apparent to me since the paper came out, and I've had so many emails saying, this is incredible, what a wonderful opportunity, this is going to change everything. I don't understand any of this data, how does it work? So it's been a little bit frustrating, I mean, not frustrating, it's been really gratifying to see people use and excited about using this data, but understand that just because we've made it available doesn't mean we've made it accessible, right? And I kind of think of it like having an amazing library, but if it's all in the language that nobody understands, then that's not accessible to you, right? You can't. It doesn't make any difference. And I worry that we're basically we've got the attention of the world with the publication come out now, and I don't want people to get frustrated by that. So I think one useful way of framing this and making this and ameliorating some of these problems is to think about these FAIR principles and applying these FAIR principles to our data. So findability, accessibility, interoperability, and reusability is something we all think about all the time as museum people anyway, right? This is something that's baked into us because we're essentially just libraries with dead things instead of books. So this is something we think about a lot, but I do think we're not necessarily used to thinking about these kind of things with the breadth of use and audience that digital information will reach. So we need to think about that. And so because museum scientists tend to think about these things often, we find ourselves in a somewhat unusual position of being well ahead of the curve for other researchers and other research fields in terms of being prepared to do something about this. So, so the Non-Clinical Tomography User Research Network, or NOCTA, it's a hard-working acronym, is a research coordination network that was created by a number of people who are probably on this call, who actually, probably not surprising, are mostly museum folks, to build a community to apply these kind of FAIR principles to tomographic data, not just museum data, not just our world, but across the entire breadth of basic and applied, basic and applied research, but also incorporating industry and educators and outreach. So if you're interested in this, is this going to work? Forward? Maybe not. Oh, maybe that. Oh, there you go. If you're interested in this, the Nocturne Network group, if you feel like you want to have a say and have a voice at this table, a seat at the table, the Nocturne Network, or you can sign up for this here. We have a bunch of resources, including educational resources, an interactive map showing where all the available CT labs around the world are. We have an annual meeting every year in person. This last one was at UT Austin, but this year will be in scenic Gainesville, Lake Alice. It won't be in Lake Alice, but I'm sure we'll find there at some point. And that's May 8th to the 10th. So if you're interested, do go on nocturnetwork.org and sign up. And thank you. I think I've run well over time, so sorry about that.
It's okay. Thank you.
AJ's next.